there is nothing you could learn. So because anything that you start understanding, the data should be formed in the form of a tangible thing. So whatever you have should be in a script. So but the problem is language emergence happened before people started writing. So that indirectly means there is no data to actually tell how the language came into being. So what the entire problem will try to address is the I don't know whether this picture is Tower of Babel. I don't know whether you guys know this. So what they try to understand is how the language came into being, because every human being tried to speak human language, but nobody knows how we started talking the language. There is no way one can actually decide or hypothesize that this is the reason that we start speaking. And when we start speaking, there is a structure to the whole language that you talk. And how the structure give him a finite number of sentences to listen. And on top of that, he can actually understand the structure that the people are talking. There is a structure to the language that everybody talks. There is a subject, there's a syntax. I mean, there's a structure, there's a syntax. And the child learns exactly the syntax. And if he's exposed to multiple languages, he becomes a bilingual, multilingual. It's not that he only learns one language, he learns multiple languages. It's slightly different from the way I talk English, because I never was exposed to multiple languages in my childhood. But I speak English because English is my secondary language, not my primary language. What it means is that I internally convert my understanding into Malayalam, and then from Malayalam I convert it into English, and then I speak. So there is a double effort that goes inside my mind. But it's a multilingual kid is totally different. He talks as if every language is primary language. So that is totally different from a person like me who is having a secondary language as English, because in my brain two computations are happening. In a kid's mind, only a multilingual kid's mind, only one computation is actually happening. So the question so this subject of origin of language, people, I think many people were trying to address. The problem is only you can hypothesize. So I can say that the language might have come this way, this way, this way. The structure might have emerged this way, this way, this way, because there is no data to actually corroborate. It's just like talking about Big Bang. Nobody knows how the universe came into existence. You just speculate. Now the point here is that the origin of language is just like that. Nobody knows the Big Bang. So the question will be like not only this. So the second problem they will try to address is this is called the origin of language. The second thing will acquisition of language, and the third one is the evolution of language. Because if you look at the Middle English at that time and the English at this time, there is a considerable difference. If you read Shakespeare's things and now you read it, there is a total shift in the way the things are expressed. So that means the language keeps on evolving. There is no way that the language is static. So that means it's like a flow. It just stays in one form, and you don't realize that through generations it is actually changing. The words, new words come in, the words die out, the structure changes, and that forms a continuum that you really did not recognize that there is a change happening, because it's a continuum. There is no discrete change that happens. It's just that that continuity is always there. You don't realize that there is something changing until you pick two sample points and two different time domains and check it. Then you see that there is a huge change happen. Until then you really don't know, because you are just the stakeholders. You just play the game and you really never know what is happening. So you all contribute to the whole process, but nobody knows that I am actually changing the language. and that minuscule change every generation will change in a remarkable change at the end, which you really recognize after you look back in time and see there is something happening. Okay, so that the things like this actually keep happening and people start studying. So 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 if you look at the whole Chomsky structure, I don't know whether you guys know this. Okay, so there is this Noam Chomsky, the famous linguist who started the subject of linguistics actually. So he had this Chomskyan structure which starts with this finite languages to all the way to recursively enumerable. So somewhere here, if you plot the human languages, you will see that it overlaps over these multiple segments. And if you see music lies in that range, the animal sounds lies in this range, and the human language which actually lies over these multiple segments. Now people started studying about what kind of languages humans can learn and things like that, but nobody could actually address the original problem, which is actually the origin and the evolution of language. So what we were trying to do, at least trying to actually address, is through. So it's just like the physicists trying to understand the universe. They run simulations in a controlled environment and try to see if we can come up with some conclusions about how things might have happened before. The same thing we also do, but in a computational modeling. So what you really do is you model something called language games. So the language games are a mechanism to actually study this problem of the evolution and the origin of languages, where you actually model everything using computational models. So when you say computational models, you place agents. So you kind of create an environment where the language might have been actually used. So for example, you will put two agents which have some kind of cognitive abilities. It has some memory, and then you put them into action. So when you say put them into action, you try to create an interaction kind of a game between them. This is usually referred to as language game, which was actually developed 20-30 years back. So what you have is two agents which have some neural network as inside, which helps them to learn something, and they are exposed or they are put out into action where they start talking. So now what you really do is a game. That means they need to talk about an idea. So what they do is they reside in a world, and then they pick some topic from this world, then they conceptualize that topic, and then they actually talk about that topic through the utterance, and which this person which actually tries to decode the whole thing without any hints from the speaker, and try to identify the object that he had actually, the topic which is actually, or the object he has tried to talk. So in this process, what you really want these two interaction to actually succeed. So what really happens is, in the initial stages, they don't have any language between them. They start with an empty slate, and when you let this action continue, and where this one agent starts speaking some rubbish or some gibberish, and then this guy tries to interpret it, at some point in time, what happens is that by luck or by some means, whatever he is trying to talk, by luck this guy might be able to decode. So when one of those interactions decodes, that the learning algorithm will try to catch on to that and try to accelerate or tries to boost that combination, and tries to decay the other combinations, and when every now and then this boosting happens, and finally what you really see is that these two people were able to talk the language. So now this is very weird to see that the entire thing happens because of luck. What happens is that two people try to talk, this guy talks some gibberish, this guy tries to decode, and at some point in time, if one interaction gets succeeded, through the learning algorithm, you boost that and decays everything else, and whenever you fails, you decay everything, you decay the thing that failed, and you keep boosting only those success ones, and then finally at the end, you will see that the success ratio keeps improving, and the two people started talking a language, and you will see that a language has emerged in this community. You will always see that whatever he talks, this guy understands. You have to understand this happened without anything between them, no bias between them. There is no preconceived bias between them. There is no information transfer happening between them. There is no telepathy happening between them, but just that by mere luck, they start developing a language. So this, nobody knows why this happens, because you are trying to boost. So this is called a reinforcement learning setup. What is really happening is that whenever some success happens in this interaction, you reinforces that success,
and whenever failure happens in this interaction, you decay that failure thing, and you keep hold of the success that is happening and decaying the failure ones, and that means that as you proceed further along the timeline, the success keeps on getting, the probability of success keeps on improving, and finally at the end it will only be success at the end. Now what we will explain is, this is called a multi-agent reinforcement learning setup, where there are multiple agents trying to achieve a common goal, and each time the interaction will be rewarded, and based on the rewards you actually boost your learning parameters. So the learning parameters are actually the neural networks that are present inside the agent. And now you will have this neural network which also acts as some kind of a memory unit. So what you really are trying to do is, you are trying to develop something called a lexicon. This is a very basic model I am talking about. So what you mean by lexicon is, each agent will have a concept space inside him, and he tries to map that concept space to words. So the whole thing is, you will see a world where the agents reside. We actually model it as a two-dimensional world. Every agent has something called an ontology. So this is the concept space. So you have to everybody understand the language is nothing but a mapping from your internal concept space to signals. So if you talk about, let's say, sunflower or something, there is a internal component and there is an the outside component, the external component. So the external component is the signals that you transmit. The internal component is the representation of sunflower inside your brain. So that means when you say sunflower and when you guys hear sunflower, it's similar kind of internal images are created, and that internal images, we call it the concept space, and the signals that you get out, those are the vocabulary that you talk about. And now finally a language will be nothing but a function from vocabulary to the concept space and vice versa, because when you speak, you take the concept space and you utter a language. That means it is, the function has to map from the concept to the signal, and when the listener hears it, he has to convert it back from the word back to the concept. So that means inside every agent, you can say an agent, so you finally call this person who, the entity which actually interacts, is called an agent. Now inside an agent, it should have the ability to actually speak and to listen. So those you refer to as a homogeneous agent, because they have the ability to do both. Now when you have the ability to do both, you should have a function inside your brain which is actually encoded as a neural network, because every neural network is a function. So you have to understand neural network is nothing but a function. A neural network takes an input, throws out an output, so it's actually a function, and this parameterized both those weight vectors. So it should have a neural network which should take concept and throws out a word, and also it should take a word and throws out a concept. It should have two networks. It's just like the human brain, which have a speaking part and also a listening part. There are two different, so they call it the mirror neurons or something. The one which does one, the mirror of that, the other one does the other one. So that means every agent should have a speaking module and a listening module, and when they talk, the speaker's speaking module is active and listener's listening module is active. And when they speak, it passes through the neural network of the speaker as an output, and it goes to the input of the listener's speaking module and then throws out an output. And then the interaction becomes successful when the input to the first neural network and the output of the other neural network matches. Now the problem you face in this setting is in the human representation. The input to the speaker's neural network is the internal representation of the sunflower, and the output of the listener's neural network is the internal representation of the sunflower. You cannot, these are non-tangible things, you cannot match these two. The only way you match is, you should have a tangible element to verify the communication. So that means the speaker should pick a sunflower and hide it, he talks it, and when the listen, and or else I have a bunch of flowers on a table which are sunflower, rose, or so many other flowers, and I utter a word after picking sunflower, not showing it to the listener, and then the listener goes back to that bunch and pick the sunflower, then only you will know that the communication is actually successful. So that means for the interaction to be successful, it should be a tangible component should be there. So you cannot actually match concept to concept, that will become a telepathy kind of a thing. You don't need that, you need a tangible. So that so that means your interaction will only be successful when there is, that interaction is actually matching the output. Now the problem you will face is Okay, I'll explain that problem also. Yeah, so yeah, okay. So the problem you will face is there is ambiguity in the interpretation. So let's say the interaction actually failed. Like, so what happened is I said something which is sunflower. The listener could not interpret it, pick some other flower. Then I have to go back and correct the listener. I would say, okay, I meant the sunflower. So that means he will actually go and tune itself back and say, okay, this word that X, Y, Z that I said indeed meant this flower. So I will actually change my mapping inside my brain and I will map it. Now the problem you will face is that if I say sunflower, the listener could not interpret it, but I told him that okay, it is kind yellow in color. But if you give feedback in that way, then you are giving an ambiguous feedback to the listener. So in that bunch, if there is a yellow sunflower and another yellow flower, that indirectly means you are actually confused between which one this guy meant. Then there is no way that the word that I said, X, Y, Z, he can actually interpret it is the sunflower that I meant. So indirectly, a human being will do is he will, okay, this can be sunflower and this can be, so this can be X, Y, Z and this can be X, Y, Z. So he will map internally that both are equally likely to be present. Now what will happen is as the interaction continues, there is very likelier chance that these overlap, these confusing things get overlapped and then it narrow it down to one element. You getting what I'm saying? So that indirectly means that you let the ambiguity flow and then it will just break at some point and then that uncertainty will break down and become one uncertain element. So that really means that as you talk more, the uncertainty will eventually die out. So those are the things that you see in these kind of things, and these are very natural things that you see, and the same thing you will experience in the same set of games that you see. So what we are trying to do is, so we are trying to model it as a setting where actually you can talk about something. So what you really do is you will have an agent. So first you have to conceptualize the world. So that means if you, there should be an internal representation, there should be an outside, external representation. So this, so you cannot model the entire complex world. So you have to pick some simple world, and we pick is oh sorry. So what we did is we developed a 2D world. So in the 2D world, there are these vertices that sit, there are these nodes that sit in this world, and these agents, they keep traveling between these nodes, nothing else. Now what they want to talk to each other is they want to pick some node from this space, and he wants to talk to another listener. So what happens is that one speaker will be there, one listener will be there. They will pair up on the same node, and the speaker person or the speaker agent will want to express this orange node to the listener. So okay, yeah, that I have actually. Yeah, I think I kept it here. Okay, yeah. So he wants to communicate this orange node to the speaker. So you can think of this world as a 2D world, and some nodes of some food resource or food present in this world, and this agent wants to tell to the other agent this orange node has the food. So actually what he means is that this source or the speaker agent wants to tell to the listener agent, this is the node that you should go, something like that. So that means first he has to express this node. So how he expresses this node, he has to actually, all the nodes are similar in shape, similar in everything except the color. So now you have to differentiate this node from this black node. What means he has to conceptualize the space. It's just like you conceptualize north, south, west, east. So how do you tell that you go to a region? Is initially the people will say you go north, then you go west, or no, you go east. There is this the cardinal directions that you all know. Similarly, what this agent will do is he will split the space into, say, this 8 sectors, and then he will also have these concentric regions which flows outwards, which are called the segments. So now what he will identify this orange node as sector 1 and segment 4. So now once he identifies this node as sector 1, yeah, so once he identifies it as sector 1, segment 4, then there is a unique representation for this node. Now you augment it with the color. So what you are actually you are calling this node as sector 1, segment 4, and color, orange color. So once you pick this combination, that uniquely identifies this particular node. Now but on the other hand, let's say there is a black one here and a black one here. I don't have that ambiguity here, so sorry. Now everything got zooomed. Okay. Yeah, now you think of this, there is a black node on this one, then you are identifying both by the same combination, which is sector 3, segment 4 and color. So there is no unique way you can identify something. It's all because in this identification, which tells you that you want to go to a house which is north, you tell them north, then you take west, and then you find the White House. If you go north and you take west and there are two White Houses, then there is no way you can identify which house you are actually talking about. Now that means whenever you conceptualize, it all depends on how much granularity you have in your brain to actually see things. So if you have a limited brain capability, like then not as an agent, I'm talking, not about human, as an agent, if you're talking, then there are certain things you can talk, certain things you cannot talk. If based on that ability of your conceptualization, only whatever you can communicate, because if you try to communicate something which is ambiguous, there is no way you can transmit that information. If I say northwest and find the White House, there is no way the person can find the White House unless there is only one White House in that region. Now the point is that, so that means if your brain has much granularity, like there is another 30 degree sector here, so 30, does it move by the waving? Yes. Oh, okay. So there is a 30 degree sector, then I can split. So it all depends how much is, okay. So that means how much granular you conceptualize, the more you can talk about. That's what it really means. Now, but
every node can be given some ID number. Why we should do the information in terms of sector?
So no,
Every node can be given.
Your objective is not to actually make something work here. You are actually trying to build something which actually mimics the real world. So when you talk in real world, you always have ambiguity. So now if you are saying that I am going to identify everything, that you are actually trying to solve this problem of communicating between two agents. Our objective is not to make people communicate. It's all about modeling exactly what you see in the world in a simple setting, so that you have to observe what comes out of these interactions and what nature of the language that comes out of it. Now when you talk about when you build this system, you have to build the world, then you build the concept space, you have to build the vocabulary, and then on top of that, the language has to start growing. It's not like you give everything to the agent. You only give the basic elements to the agent. This is actually opposite to how the physicists work. Physicists always take an element, cut it into pieces. They cut it into molecules, then they cut into atoms, then they cut into electrons, neutrons. They go a top-down approach. Here what you see is a bottom-up approach where you build the basic elements and you see what comes out of it. So what you are really seeing is you are giving the agent the cognitive abilities, you are designing the world, and we are setting the protocols how they should talk. Now it's up to them to follow the protocol, and then as a developer of the whole setting, you have to see what comes out of it. There should not be any external so there is nobody plays God here. The point here is everything is the decentralized one, and you have to see what comes out of it as a output of the whole setting. Now what we usually see is a language comes out of it, and that is the most beautiful thing in the whole setting. You see something comes out of it, and that has a shape. It's just like you keep I don't know what you do, the curd you keep on doing, something emerges out of it. Nobody controlling it, you are just churning it, and finally something comes out of it. It's exactly the same thing. You really see is you just set the rules right, let the agents play the game, and see something coming out of it. And that coming out of it is not something random, it's something which has a structure. The structure can be in the form of a syntax, it can be in the form of a word order, It can be form of anything you want, but nobody controls it. Nobody tells him that, okay, you pick this syntax. It's natural that they develop it because they do it through trial and error. They always try something, they fail, they have some kind of activation that happens inside, and actually that activation will be flowing around, and then finally they will find some combination which works, and that actually emerges out of it without anybody actually controlling it. So that's very, very important. It's a decentralized, uncontrolled thing where something comes out of it through simple interactions. Now, this has gained popularity recently because the DeepMind or those folks are actually trying to develop robots which can actually start talking to each other. So it's just like they don't frame their mind to actually talk English or anything, but rather they want that robots to develop language for themselves. So once you develop these kind of things, through the interactions they start developing the language which is only required for the agents to actually exist in the group or the world they actually they don't want a language which can explore the whole world. They just want the robot to actually explore that environment they are staying. And this kind of settings will actually help the agent to actually develop a language in robots which can actually talk to each other, which may be totally different from the English language, but they have a similar structure like the English language, so or any other language. Any kind of communication it works, yes. Because so it's something which.
People told that it is not desirable.
Oh, is it?
They themselves try to communicate, and it may, without any control, it may affect the situation.
Okay, okay.
Very recently.
Okay.
It's called what is it?
Okay. Okay. Standard protocol, yes, yeah. So this kind of things you will see when you build this kind of environments, yes. So what we did is finally we developed some kind of a neural network. So finally it goes down to, I am not going to go into details of this, but it's, when you model these kind of things, even though it's easy to explain, it's actually very hard to actually work it out. Now, when you say you have to work it out, finally what you are trying to do is you have a world. So you have a world, the world has some nodes in it, he wants to communicate one particular node to it. First it has to go through the conceptualization module, then it will conceptualize as some sector, segment, color, then it passes through a speaking module. The speaking module will tell, for this segment you pick this word XYZ, then for this segment you take ABC, and for this color you would say C1 or something, and finally these signals will transmit from one agent to the other. So what will happen is, okay, it's very simple. The world is here. The world will be, he picks one vertex, the listener. The listener will pass through a neural network which will tell what are the concepts you should pick. That concept will pass through a speaking module which will utter what messages you should transmit. The messages will come back to the listening module of the speaker, the listener, and the listener will, touch it. Yeah, the listener will actually utter the concepts that those words meant, and that concepts will actually be applied to the world again, and he will. So it's okay. No, I actually by mistake I touched. Yeah. Oh, okay. Oh, okay. Oh, sorry. Yeah. Sorry. Oh, this is for, yeah. All right. Yeah. Thank you. Yeah. Yeah. All right. So, so what happens is the speaker. Okay. Yeah. Yeah, it's there, but on the screen it won't. Okay. Yeah, I'll just say. So it's just everything is neural network. Nothing else is there. It's okay. I can use my hand from here. Yeah. So it's just the world comes in, the concepts comes out, the concept goes in, the words comes out, words come out, then the words go in, the concepts come out, the concept applied to the word, it will pick the vertex. So it's very simple, nothing else is there. So it's just that the neural network parameters has to be updated. So the only thing you have to really understand is the speaker and the listener has to independently move their neural network parameters. What happens is, if you let's say the interaction went through and then the speaker and listener were able to communicate successfully. So then that means you will get, so it's a reinforcement learning. So that literally means that you will have a reward that passed back. So it's just a reward based thing. So the agent, he does an action. This action will be finally the word utterances that have, and the environment is the whole setting that it resides in. And every time when the interaction happens, the action, you have to see it as the action from the speaker's side and the listener's side. And when the action becomes successful, you'll get a reward. That reward will be a positive reward if the interaction is successful, if it is negative, if it is failure. And that reward goes back to the agent, and the agent means the speaker and the listener will actually calibrate their parameters according to the reward they got. So what happening is that when there is a success that happens, they both calibrate towards the success. And when the failure happens, they actually deviate from that common thing. And what you really see at the end will be a coherence that emerges out. And it's just through the reinforcement.
When will we say that it is success? How do they calibrate?
Exactly. So the point here is it has to be, there should not be a third person who tells whether the interaction is successful, but they have to identify by themselves. That's what I was trying to say. It has to be like the flower has to be shown to the speaker, the listener at the end, to actually verify whether my interpretation was correct or wrong. So here what happening is, so what is happening is the orange one, if the speaker picks and he utters the word through segment, sector and color, the listener will actually interpret each of these words separately. So he will get a sector, segment and a color, 3 different way. Then both are sitting on the same vertex. So they will apply, the listener will apply that to his space. So then he will identify this is the region actually he meant, because he also conceptualized in the same way as the speaker. That is an assumption we all make. The way I think, the same way the other person also think. So that means he will identify this region. Once he identifies this region, then he look at how many vertices are there in that region. So he only, since he identified the region and he identified the color, so there is only one vertex in that region. Now what happening is that the listener will actually move to that vertex. Now if he moves to that vertex, then the speaker knows whether he picked the right vertex. So it's very simple to actually identify. So let's say there is a black one here and another black one here. Even if he identifies the sector and the segment, he cannot identify the vertex because there are 2 choices. So that means the communication will fail. But let's say there is a orange one here and a black one here. He identified sector and sector correctly, but the color he could not identify it correctly. Then let's say by wrong mistake he went to the black one, then the speaker and the listener can nod their head and say, okay, you are actually failed. So that means there is a tangible way here to actually identify my interaction is successful or not, and through which actually they can actually reinforce their individual parameters. And when the success happens, they go together. Then the failure happens, they deviate from each other. And when the success, and eventually when the success starts accelerating, then the coherence start emerging out. That's how it works. So there is no way theory can explain it. It's only through experiments only you can actually see this happening. So okay, so it's just the particular ambiguity that you will face is a typical. This problem is called the Gavagai problem. So there are 2 kids, and this kid utter a word called Gavagai. This is a thought experiment. So it's called the semantic indeterminacy. So this kid said Gavagai, and this kid has never heard about the word Gavagai. Now what happened is that this kid wants to teach him what the word Gavagai really meant. Gavagai, she meant actually it is a rabbit. So what he did is she cannot show but she just pointed to the region rather than to the rabbit. So when this kid hears the word Gavagai and the feedback that is coming from the child in the form of a gesture, in the form of a pointing, he is still not able to identify what the Gavagai actually meant. He might be thinking it's a rabbit, it can be the grass, it can be ear, anything it can be. So there is an ambiguity in every interaction. There is a context of ambiguity, and even if you so what I am trying to tell here is, if this interaction fails, if this interaction fails, then the speaker has to tell the listener what actually those words really meant. So what he really does is, when the interaction fails, he gives a guided feedback. What he does is, the speaker will go to the topic vertex what he meant, and he will stand there. So the listener will be able to see what he really meant. But what he does is that vertex will, so then he will use this conceptualization to identify the sector, segment and the color that the vertex belong to, and then he will try to map the heard words, the words that he heard from the speaker, and map it to these individual concepts he obtained through that feedback that he received from the, it's just like pointing to a context and telling him what I really meant by actually going to the source vertex that you really, you getting what I'm saying? Yeah, okay. So that means what we do is, without feedback the system will not work. So if I am telling that I am trying to teach a person what sunflower meant, I cannot keeping trying and until he picks the right one. But rather I will do is, whenever he fails, I will show him this is what I meant. Either do that with 100% accuracy, or you make it some kind of ambiguity you install, like this region has my topic, something like that. So, but naturally when you have language being developed, you cannot say everything is 100% determinate. It is actually that context of ambiguity will always be there. So what we are trying to say is that this ambiguity is always there in every language emergence, that this is called the typical Gavagai problem, when even the feedback will not be sufficient to actually interpret the right result. This is usually called the poverty of stimulus, because your stimulus is not entirely helping, it's actually still poverty is there. That means you are unable to interpret the true meaning. So what you are trying, so in this our game we actually modeled everything, and the results that we obtained are a bit very nice. So so what we finally got is we have 4 agents which actually ran these experiments, and this you have to think of, this is the vocabulary of the agent. So what is happening is this lexis is the words of the agent, and the concepts are the concepts inside the agent. There are like 12 concepts for each agent, and 25 words inbuilt inside each agent. So you have to understand, every agent has a bag of vocabulary, that means a bag of words. It's just like any human can generate any signals he can produce within the frequency range. So we are assuming every agent has 25 words in it, and every agent has 12 concepts inside his brain. No, we have no. I cannot communicate. So that assumptions are very standard. So you have to make sure that everybody has a set of concepts. Now same set of words also. Now what you are seeing is, in the beginning everything is so random. This guy's vocabulary. So when you have to understand this, bright one means probability 1. So the dark one means probability 0. So what is happening is all of them have different vocabulary, and at the end when the interaction finished, what you are really seeing is that this concept number 1 has word number 24 being mapped, is it? So it's like concept number 1 has a word number 24. Here also concept number, so I think I got it wrong. So I think I should, yeah, this is concept number 10. So the 1 is missing here, is 0 to 10. So concept number 9 has a word number 24 mapped. Here concept number 9 has word number 24 map. The same thing goes here also, same thing goes here. So what you're really seeing is that the bright ones are same for everybody. The bright ones are same for everybody. That really means that everybody is speaking the same language. So I don't know whether able to communicate. So it's so there are 12 concepts. The word corresponding to concept number 9 is word number 24. 9, 24. 10 is 20. 10 is 20. So everyone else is dark. So that means every concept has only one word associated with it. There is only one word. There is no homonymy or nothing. It's just that every word has the same, every concept has some word, and some of the concepts never have any words. So that indirectly means that some of the concepts, they never talk. It's just like some concepts die out. Even though they have concepts which are there, they are never using it. That means they are never actually having a word for that. So that literally means as the world actually, the language that emerges through interactions actually reflect the world that it really represents. So that's what, so we have developed different hypotheses. So the first hypothesis that we found is that every language is Sipaffian. So I don't know whether you know Sipaffian. That means every language you take has this characteristic that the most frequent word and the second frequent word is the if you plot the graph of the frequency of usage in any text, you will see that the graph will always look like this. So the graph will always, you take any human language, every language is Sipaffian. That means you take any standard text or anything, you plot the frequency of the most frequent word followed by the so the frequency of the words, you will always see that the most frequent word and the second frequency word is almost double, and the third one will be half of it, the fourth one will be half of it. So this characteristic is there for every language. If you take any language, Hindi, English, anything, and you take a standard huge text or something, or a corpus of words and textbook or anything, and you plot the frequency of words in that corpus, you will see that the most frequent word and the second frequent, ours is not entirely matching, but I'm saying it will be half of the first one. Then this is an exponential decay. So that is common for every language in the world. This characteristic is called the Siphovian characteristic, and so this graph is called the Siphoff distribution. So now what we also found is that we are almost the red one is the Siphovian. What we are getting is the blue one, which is very close to the Siphovian. So our agents were able to generate Siphovian characteristics in the language that they generated. Now what we also see is that we also instill some kind of a concept called the no. What I mean is this for a particular language. Yes. No, if you take one language and take some textbook, so you cannot count the frequency. You have to take a textbook or something, some big textbook, and you plot the frequency of each word.
The same language?
In the same language, you will see this graph being followed. So same for another language also. As an example, same language, yes. Every language. This is a global characteristic, yes. So because if our language that the agents are developing doesn't comply with the human language, it doesn't make sense. So what I'm trying to show is that these languages that the agents are developing are actually having some characteristic which matches with the human language. So these are the certain statistical characteristics we can match. We cannot do anything else other than do a statistical match. So now we have some results maybe. So what this tells is that so the entropy in the system. So entropy really means how much uncertainty is there in the system. That means if I talk something and I am ambiguous about what word to use, that means the entropy is high. So what we are trying to see here is that as the speaker and listener speaks, the speaker's entropy dies out eventually, and the listener's entropy also dies out eventually. That means the listener and the speaker are actually becoming certain about how to solve the problem. So it says that the speaker is able to tell this is the word I should be using for this, and the listener is also certain that this is the word this concept really means. So what you're really seeing is there is uncertainty about speaker and listener. There's a transient phase, and as time goes on, they are actually able to decide, okay, there is only one word for this concept, there is one word for this word, there is only one concept for this word, and they both are able to learn. So when the entropy dies out, what it really means is that there is no confusion. When I hear a word, I know what the concept is, and when I have a concept in it, I know what the word it is. So both are able to actually come up with zero entropy, which means that they're both learning to talk. So and yeah, I think and this is just a statistics which tells that if the world, so there's a standard theorem by Warp which says that the language is shaped by the environment it resides. So that means if I reside in a small environment, I will only use certain concepts, even though my brain has more abilities to visualize or conceptualize. So if I have only in a world, if I have only tables and chairs, if I am in a closed room and I have only table and chair in my room, I will only be thinking about table and chair. I cannot think about anything else. So that's a Wolf statement. So what we are trying to say is that if I have an agent which resides in a world where it doesn't have to use all the sectors and segments inside his world, if there is only one black node in the entire surface, he will never talk about orange and red. He will only talk about the black node. So what you're really saying is that there are certain concepts. So this is one interaction where this hash marked are the concepts. There are 12 concepts, but he's only using 1, 2, 3, and 4. The remaining are all very minuscule. So what it really tells is that in this world he's only using 4 concepts, even though he had 12 concepts in his brain. So these are the hypotheses we are trying to verify. So there are 4 hypotheses which are very standard. We actually verified that this can actually work in our setting also. So I think I'm fine with the time. Okay, so I think yeah, that's it. So I'm just trying to tell how to see it other than LLMs. These are one example where I can actually work in a setting where I can. So this actually comes under the domain of computational linguistics. Doesn't come under the true nature of linguistics. So if so this yeah, that's it. So so this is the best I can do.
All right, I think I will stop here. Yeah.
It may not be. It may be not be common.
Understand.
It's very. Why?
We have to, the problem statement itself is not clear.
No, no. It's the problem.
What context we have.
So if you think about Chomskyan thing, I don't know whether universal grammar thing everybody knows. Yeah, it's a very controversial topic. Nobody actually know whether it is right or not. But some people support it, some people object to it. So these are hypotheses which actually nobody can verify unless you have a model or a system which can actually show these kind of things happening, complying to that results or something. So we are not going that way to the universal grammar.
Never came to some conclusion.
Chomsky,
Gravity goes on improving.
yeah, that's what. So everything is speculation. That's all hypothesis only, unless somebody actually can claim that in this setting at least this is working. Okay, okay. I am not sure. So I know that universal grammar is a bit controversial. That I don't know much. Chomsky. Okay, okay.
I request Kalyan Ravi to summarize the picture and Chandrasekhar to explain.
Good evening, everybody. Firstly, I would like to thank Dr. Ajit for his insightful and exceptional presentation. Please sit, sir. So I would like to draw a few parallels between what he has said and what is there in Sanskrit. So I was earlier working in a department called Shabdabodha Systems and Computational Linguistics. So in Indian perspective, like you had said, how do you know what this word means? So we have the concept of Shabdartha Sambandha. That is number one. So how does communication happen? So in that there are two concepts. One is Artham Buddhva Shabda Rachana, and the other thing is Shabdam Buddhva Artha Rachana. That is from the speaker point of view. You understand something, you want to communicate a particular X. So you have to understand whatever you want to communicate, and then you have to code it in the form of words. So that is from the speaker point of view. And then Shabdam Buddhva Artha Rachana. The listener, he will listen to whatever the speaker has said, the words, and he will again decode them into their respective meaning. And if party X and party Y come to a common ground, that is where communication happens. So this is what it is very very primary. So this is one thing. And the next thing is, like you had given an example of a sunflower. So how do you know that whenever you see the word or whenever somebody utters sunflower, how do you get that mental image? So you had even said that there is something known as internal and internal and external. The same is told in Vyakarana also. So we have something known as Bauddha Padartha. Bauddha is something as Buddhi. It's a construct of your mind. So, and how do you derive to the meaning of the word? For that, there is a very beautiful karika which sums up. Shaktigraham Vyakarana Upamana Kosha Apta Vakyad Vyavaharatascha Vakya Seshad Vivrater Vadanti Sannidhyataha Siddhavadasya Vruddha. I think after listening to it, most of your talk is very related to Vyavaharat Shaktigraha. So here what happens is, you are giving the example of how a young student picks up language, one young child. So when we say Vyavaharat Shaktigraha, there is an old man, there is a young man, and then there is a child. So he says Gamanaya. The elder person says Gamanaya, or he says Gamanaya, Gam Badhana, Gamanaya, and so on. And the young kid, he is observing the small kid is observing the young man. So whatever command is being given by the elder person, he is doing it. So the common point there is Gam, Gam, Gam. So at one point the action is bringing the cow. In another scenario he is tying the cow. And then in another scenario he is taking the cow elsewhere. But the common factor in all these is Gam. So we use something known as Avapa Udvapabhyam Padanam Tatra Shakti. So which is what you said, permutation and combination, trial and error method. So that is how you come to a conclusion that the word cow means this particular animal. And then I think in the realm of Shabdabodha, Vyakarana, Nyaya and Mimamsa, all these three darshanas play a very important role. And one more thing which I think could be related to this is, Mimamsakas have a very peculiar theory. So, nobody has uttered the word Shveto Ashvo Dhavati. They have not uttered this sentence. But then they have pointers to this word which ultimately brings out Shveto Ashvo Dhavati. So, Pashyati Shvetima Rupam Hresha Shabdam Tashrunataha Shveto Ashvo Dhavati iti Bodha. So, if I say a white horse is running, then you will understand there is a white horse and the action which it is doing is running. But I will not utter the white horse is running. Rather, I will come to this conclusion based on a set of proofs. Pashyate Shvetima Rupam. He has seen only white color and he is not even sure that it is a horse or some other animal. And then Hresha Shabdam Tashrunvataha. He listens to the neighing of the horse. And all these factors contribute to the ultimate result, which is Shveto Ashwa Dhavati. And I was very surprised when you said that Gavagai example. We have something known as Go Sadrisho Gavayaha. Gavayaha is probably Neel Gai. So we use it in the sense of Upamana, analogy. So in that thing, so Gavayaha and Gavagai I think are very closely related, and I think the similarity is very uncanny. So thank you, sir, for a very insightful talk, and I hope we get to listen more of you, and there is some good collaboration between your technological university and our traditional university, and I hope CDAC people play the synergy in between. So thank you for your lecture. Thank you once again.
Thank you very much, sir, for your wonderful session. And now I am requesting Professor Chandrasekhar, sir, head of the Department Computer Science in our university, and Anna Rao Kulkarni, sir, from CDAC team. Please felicitate today's keynote speaker, Ajin George Joseph, sir. Please, sir. Sir, you also please join.